So I found out that Uber was doing it with transportation, Airbnb with accommodation. So I tried to do it with energy. And what I'm talking about is selling excess electricity to your neighbor. And I called it Ubering energy on the blockchain. Now, when I first came up with this idea, I thought it was the best thing since sliced bread, very unique. Needless to say, after searching on Google, I found that a lot of other people were talking about it, and in fact, some had even built it as well. And in fact, just talking to this evening, Jonathan there has showed me all about his project. The key is that it didn't stop me, because what it allowed me to do was to bring all my research from Bitcoins, blockchains, and smart contracts into a project that I could share and show people and for you guys to see and experience. Here's a quick intro video that I created. So I came up with this idea over 18 months ago, and over Christmas, 4 months ago, I started thinking about it and designing it, and in the last 2 months, I started building it, as you saw some of the components there. There were 4 steps in the project itself. The very first one was, I had to find some way to get the data. The second step was to store it somehow. The third step was to allow the users to visualize the information. And the last step, the most exciting part, was to try and sell it to my neighbor. So the electricity meter reading industry hasn't changed much since the 1800s when electricity was first invented. Sure, the meters may be smarter, but I thought that there was a bit more that I could do with the information. What I wanted to do was to truly own the data myself. I wanted to get more of it, and I wanted to use it to help me make better decisions. Have you ever wondered who owns the meter data at the moment? Is it you as the consumer? Is it the meter reading company? Or is it the retailer who uses that to give you a lovely bill every month? What I did was I started out building a meter. I got a breadboard out of the shelf. I had to dust it off. I got it from Dick Smith Electronics back in 1988. Bought a whole bunch of components, and that blue device there is an Arduino. It's basically a microprocessor. It's been over 25 years since I've actually done this kind of stuff, so when it actually worked, I was over the moon. I almost fell off my chair. I was high-fiving myself because I never actually thought that it would work. When it did, I had to make sure that the numbers were right. So I had to calibrate it. So the clamp's up the top, and this is an amp meter. I turn it on, and that's showing about 6.8 amps of a heater. And the data on this side here, you can see it's streaming. It's also about the same. So I knew that it was kind of working. I was really happy with that. The next step was to allow the microprocessor to talk to a Raspberry Pi, this green device, which is a mini credit card sized computer. I used the Raspberry Pi as my gateway to the internet, the IoT, so to speak. Here's a picture of the board that I built. I couldn't bring it from Wellington, unfortunately, but if I could, it would have been sitting right here. I tried to mimic a household distribution setup, where you've got your switchboard up above, light switches, power sockets, and obviously the various components you can see here that I've been talking about. So after I had a way to measure it, I had to find a way to store the information. And I didn't want to use a regular database such as MySQL or Postgres, because if I was to scale this thing, then how was the other person using the solution going to store it? And I certainly didn't want to hold it as well, because I'd be a meter reading company. So what I did was I used a solution called IPFS, which stands for the interplanetary file system. What this does is it allows me to take the data that I'm reading, break it into smaller chunks, and then store it around the world in a distributed and decentralized fashion. This is something that I've done that I think is unique, because people who read data, they want to hold it, and I'm doing the exact opposite. After I stored the data, I had to find some way of displaying it to the user. What I did was I used an application in the cloud called pubnub.com. And pubnub stands basically for a publish and subscribe integration architecture, where the Raspberry Pi, with all the data, could publish it into pubnub, and Freeboard.io, which is an open source dashboard application, could subscribe to pubnub and show the information in real time in a dashboard here. You can see this dashboard has, say, temperature, current cost, and the power consumption in your kitchen, your living room, your garage, for example. So just a quick recap. Step 1 was to get the data. Step 2 was to store it. And step 3 was to show it to the user. Step 4 was, how was I going to use this? Well, I decided to sell it to my neighbor, sell the excess electricity. And obviously the context here is around solar panels, because you have to be generating excess in order to go ahead and sell it. Here's a question. How many of you guys have solar installed in your house? No one. Has anyone thought of installing solar?
Yep.
A couple? Yeah. The way it works is that during the daytime, usually everyone's at work or at school, so you've got excess electricity. You can either store it in batteries, or you can sell it back to a retailer through the grid for next to nothing, really. So I thought it might be fun to take an extension cord and chuck it over the fence and see what happens. The tricky part was, how was I to charge my neighbour or bill? Was I going to knock on his door and pick up 23 cents every day, or bill every week or every month? That's where the idea of smart contracts came into play. The smart contract allowed me to set up an agreement with my neighbour. It's basically a piece of code, and put it on the blockchain. This is what a smart contract looks like. I've heard a lot about it, but actually seeing it demystified a lot of it, because actually it's just a bit of code, as you can see. It's got a name. At the top I call it Empower. A whole bunch of variables that I've declared, and a whole bunch of functions down below, such as top up, get last top up amount, get balance, and bill user. With this contract here, you can see the rate here is 26 to indicate 26 cents per kilowatt hour. Obviously, if you were to trade or sell to your neighbour, it would be more than what you get from the retailer, but less than what your neighbour pays. So here's a demonstration that you saw in the intro, where the current is being read through the microprocessor, getting sent to the internet via the Raspberry Pi, and you can see I'm just dialing it down, and it's actually quite responsive. I was quite surprised with that, so it's not too bad going over the internet. And obviously if I had the actual device here, it would be a bit more impressive. After that, this demonstration here shows you the smart contract that I created, and I deployed it on the blockchain. What I've used down here is something called Test RPC, and it simulates the blockchain on your local laptop. You can also use testnet if you want, which is the Ethereum test blockchain. But what I found with that was it took about 20 minutes to actually get up and running and to synchronize, and it made the whole process a lot longer. Whereas this one here, I could go through the whole simulation in under a couple of minutes. Just going to hit play. At the top there, I'm just running a function called top up, and I've got 100. I hit enter, and then I get a hash return. And I've got a little GUI on the right-hand side showing me the numbers, basically, of how much I've topped up. So I'm going to top up again with 300, I get a hash return, the block number has increased. I refresh the HTML page. You can see the last top up is 300. The balance is now $400. Next, I'm going to run another function called bill user, where I'm going to put 1 to assume that the neighbor has used 1 kilowatt in 1 hour. And then hit enter. That's on the blockchain. And then hit refresh. And you should see the bill amount there as $26 per kilowatt and subtraction take place. So it's actually just a web page with interaction via an API onto a simulated blockchain there. So what did I learn? Well, first of all, this stuff wasn't easy. The software and the hardware that you saw, I had to create from scratch, and I had to learn from scratch as well. But the key is that it's not impossible. And if I can do it, I'm probably no smarter than you guys in the room. You guys can do it too. You just got to do a lot of reading and research. The most exciting part is where to from here. You saw on the dashboard that you can actually measure the power consumption in each room of your house. Kitchen, your lounge, your dining room, etc. What's also exciting is that if you are given an electric company car and you're charging it at home, you can find out how much it costs in order to get reimbursed from your company as well. You can also overlay analytics on top of the data itself, and the dashboard could become smart and suggest to you, hey, did you know running your dishwasher after 11 p.m. at night could save you $2.36 because you're on a day and a night rate? Instead of selling electricity to your neighbor or back to the grid, you could sell it in a decentralized marketplace. And these are being built as we speak. And of course, the example that you saw here, it was just a token. It wasn't tied to a cryptocurrency, but you could connect it to a Bitcoin or an Ether or a Litecoin, for example, as well. Where do you guys fit in? Well, I made one mistake, and I did this all by myself. I spent a lot of time reading and researching. If I could do this again, I would have utilized the community, meetups, networking, collaboration, because technology is moving as fast as we've ever seen before. So the secret, really, I believe, is to learn and to learn fast. And what we have here is also a community, an association, where we can leverage the knowledge and the ideas of one another. And I hope, what I believe in is bringing all these ideas to reality together. So in conclusion, you saw that I went ahead and I built a meter to grab the data. I found a way to store it in IPFS. I then used an open source dashboard to allow the users to visualize the information. And then I also wrote a smart contract to put it on the blockchain to sell it to my neighbor. So I hope this talk has been interesting. I hope you've learned something new. The power really is in a community coming together and collaborating and bringing all these wonderful ideas that I'm sure we all have into life.